want to do the questions and yeah, on the content afterwards at the end of his presentation, we can then do it either by you can raise your hand or you can put it in the chat. Then we can address those. And that also brings me to yeah, introduction of Mr. Egbert Spaans. He is an expert on well, agronomist, background in Wageningen University, but also he did a PhD in soil physics at the University of Minnesota in the USA. He has been working mostly in Latin America, working and advising many companies and projects on agroforestry, in particular cocoa, bananas, sugarcane, and oil palm. And I know him through a project as well in, well, I got the contact of him through a project in Nicaragua, where they intercropped cocoa with teak. We'll see some pictures there as well. And yeah, I'm very happy he's among us. He's based in Ecuador, which has a heavy security situation now. So yeah, I'm very happy that he still could make it despite the situation there. And yeah, that leaves me with giving the word to Egbert. And yeah, please go ahead, Egbert. And oh, sorry, one second, Egbert. Now you can turn on your microphone and start. I think you have to still enable your microphone, Egbert. There you go.
All right. Please confirm that you can hear me and see the screen.
We can hear you, but we don't see the screen yet. Well, we see you, not the presentation yet.
My sharing is again deactivated. Maybe you can activate my sharing again.
Yes, yep. Now it should.
There it is again. Now, come up. It doesn't appear. Bear with me 1 second here. Because the PowerPoint doesn't show up on the options of sharing. Hang on a second.
Saw your screen for a second.
Yeah. Now you see me. Do you see the presentation?
No, we see a white screen now. It's weird. Is it?
Yeah, yeah, I got it. Quite.
Yes.
Yeah, can you see it?
Perfect.
All right, and can you hear me good?
That's also good.
Okay, then I'll start. Well, good morning, good afternoon, everybody. I think we're all in different time zones, but I hope you're doing well, and I would like to take the opportunity to thank Rabobank and the Acorn Group to invite me to give a presentation and share my experiences and studies on agroforestry systems, particularly with cocoa. And so in this presentation, we will have three chapters. On the first part of the presentation, we will talk about the purpose of multicropping. Obviously, agroforestry system is a special case of multicropping, but in general, it's very interesting to really see why we would do multicropping. Then on the second chapter, we will dive into a little bit more of the science behind the plant responses to solar radiation, which is which will turn out to be one of the main considerations in the design of agroforestry systems. So that is a theme that we will have to dive in and really thoroughly understand in order to see why certain agroforestry systems work and others don't. And then at the end, we'll try to put everything together and look at a couple of examples of successful and unsuccessful designs of agroforestry, and what we really will see in that the successful design in agroforestry is really an art of finding the right balance between the different crops in the system. So let's start with the purpose of multicropping. Now, what is multicropping? And we see that on the left. If we have a 1 hectare farm, we could put a fence in the middle and divide it into half hectares, and then we can plant crop B on the left and crop A on the right, basically dividing our farm into monocrops. Yeah? But we can, as the arrow indicates, we can also decide to take out that fence in the middle and take the whole hectare and just plant A, B, or in any other configuration that we find suitable. And so then the big question comes, so we go from monocropping on the top to multicropping on the bottom. And then the big question is, why growing more than 1 crop on the same field instead of 2 monocrops on adjacent fields? So that is really the question that we should ask us. And we will see that there is various arguments and reasons that might be beneficial. And then we will see in the next slide reasons why that could not be beneficial. But let's look at the benefits first. One of the main arguments for doing multiple cropping instead of monocropping is if there is a mutual benefit between the 2 crops. Yeah, and there can be different benefits. For example, crop A needs shade that crop B can provide. Then obviously the upper configuration is less beneficial, and it would be more beneficial to have the lower configuration where we have A underneath B, and in that configuration then B can provide a perfect shade for A, if that were the case. Another argument risen, particularly in the literature, that crop B, that could be the trees, yeah, they have deeper roots and they could eventually recover some leached nutrients from greater depths where A doesn't reach. And by recovering those from greater depths, they bring it up, it goes into their biomass, and then as the leaves and the branches fall back onto the ground, we sort of recover nutrients from greater depth into the ecosystem where then A could benefit again from it. And then obviously the configuration below, where we have them alternating, is more beneficial than the configuration above. Similar to that, we can have a situation where crop B repels pests and pathogens that affect A. And then obviously it would be more beneficial to have them closer together, alternating, so B can have a better effect of repellence that would benefit crop A. So those are three arguments amongst maybe others, but those are the three main arguments that are used to show that there might be a mutual benefit between the two crops, and therefore they'd be better closer together. There's also an argument of increased biodiversity. Yeah, if we have the plants, the genetically different plants A and B, if we have them more mixed, then we will get a more diverse residue on the ground, because leaves and harvest residues from both A and B fall together, and the more diverse the residue composition, the composition of the plant residues on the ground, the more diverse they are, the better we will have decomposition of those residues, and therefore a better microbial diversity in the topsoil. Also, a benefit could be that plants of the same species are more distant. So the distance between two A plants, between the rows, is larger in the lower configuration than in the upper configuration. So if there would be pests and diseases that affect A, the further they are spread out, the least possibility are that pests and diseases propagate throughout our plantation. So these are two very important arguments to go to a multi-cropping system. I should mention, and this is a very personal opinion based on study and some experience in the field, that the recovery of nutrients up back into the system is more intuitive than really some of these benefits have not been able to prove them consistently on the farm. Yeah, if you think, for example, if A were a banana crop that suffers from sigatoka, black sigatoka disease, even having them spaced further apart with the B crop between them, the sigatoka would still jump from A to B. Yeah, and also the repellence effect, for example, of certain crops. In Latin America, they talk a lot about the nim, which is a tree that would repel insects, and that repellence effect also has not really been proven consistently on a large scale. So I would really like to focus on in the mutual benefit between the crops. It's really the first one that I see as the most important, and on the increased biodiversity, also the first argument that we have a more diverse composition of our organic matter on the soil. I see those two as probably the main advantage of the multi-cropping compared to the monocrops. Now I would like to go to another argument, the third argument, and as we will see later on, that for me is one of the strongest arguments to go to multi-cropping, and then we can really see this would be sort of the agroforestry system that we are trying to propose. And that is the C argument, and that is the last configuration on the bottom. And that will work in case crops A and B do not compete, yeah? But with this configuration, we can increase effective area. And what do I mean with this? With increasing effective area, we would basically plant our main crop, which is A, and that could be cocoa, and we would plant that as if it were a monocrop at the same distance, at the same density. So we would have 1 hectare of complete crop A. And then we try to insert crop B, which would be the trees, within that crop, but such that they do not compete for area. Yeah? And so if we think of an agroforestry system with cocoa, then A could be the cocoa and B could be the tree. And since the cocoa, as we will see later on, does tolerate some shade and doesn't need full sunshine, then we would create almost a situation as you have in a natural rainforest, where you have different canopies at different levels. You know, if you look at the different strata in a tropical rainforest, where if you have very tall trees at 20, 30 meters height, you know, catching sunlight, and then there's a second story and a third story and maybe even a fourth story, all plants at different heights. And they all capture some of the light that the other ones let through. And so that is sort of what I'm proposing here, and what has shown to be quite successful, because in this configuration, we have 100% of the area covered with crop A, and then according to the conditions on the area and depending on the species we're using, we could in that same area have maybe 20 to 40% of the area covered with crop B. So we would really, in 1 hectare, we would be growing crops equivalent to 1.2 or 1.4 hectares if we compare that to the very top configuration, where we would have them as 2 monocrops. And this is a very interesting configuration, particularly for small farmers that may not have large areas. So if you have only 5 hectares, a small farmer that has only 5 hectares, this way he could harvest and benefit as if he had almost 7 or 8 hectares equivalent. And so that I see as the big benefit in agroforestry. And of course, one of the main combinations that we will treat here in this presentation is where A is cocoa and B are trees. I should maybe clarify when I talk about cocoa, because if you look at the literature, cocoa is used, and some say, well, cacao is one thing, cocoa is another thing. If I talk about cacao or cocoa, I basically talk about the crop, the plant, the tree of cocoa, and not the beans or the paste that is also called cocoa. So we can see some examples here. This is an example of multicropping in Brazil, in the state of Bahia, where this is a very common combination of rubber, Aveia brasiliensis, and cocoa. And so what we have is we have 2 rows of rubber, and then 3, 4, 5 rows of cocoa, and then again the rubber. So this rubber provides the shade that is under these circumstances beneficial for the cacao. But in this configuration, so this is a good combination, because the rubber provides some shade for the cocoa, and the 2 are not competing, because the photosynthesis of the rubber occurs at a different stratus than the photosynthesis of the cacao, which is a lot lower. And as the experience has shown, the roots of the rubber are not aggressive and do not affect the rooting system of the cacao. So this is a good combination. The only if that I have is that we are multicropping, but we are not increasing effective area. So here on 1 hectare, we still have half a hectare cacao and half a hectare rubber. Now this is another configuration, and this is from the area Rio Dulce in Guatemala, where I have a couple of agroforestry projects with farmers. This is on the Atlantic coast of Guatemala. And so what we have here is we have a cacao crop with the regular 1,250 plants per hectare, which is the normal density and the optimum density for cocoa. But then within that crop, they planted mahogany trees. That is a very valuable tree has a very high price. And it was planted sort of equally spaced, so you have a very nice shading, and you can again see that they do not compete. The photosynthesis of the mahogany, it's called the caoba in Spanish, occurs at 7, 8 to 10 meters height, and then the cocoa has its photosynthesis at 3 to 4 meters height. So, and the shading of the cocoa of the mahogany is at this stage almost perfect for the cacao. So in this case, this farmer, on each hectare, he is really producing an equivalent of 1.4 hectares. 1 hectare cacao and 1.4 equivalent of mahogany. So, looking at the purpose of multicropping, why would we not do multicropping? So where does multicropping really doesn't help the farmer? Well, that would be the case if you had 2 crops. For example, as we see in this picture, we see corn on the right and soybean on the left. And this is obviously not multicropping, but I show the picture to see how the crop on the right that has a different height and a different growth speed than the crop on the left, there's a clear light competition. And the light competition, and that's why I show the picture, the light competition you can see on the first 3 rows of the soybean that are adjacent to the corn. Now, could you imagine if this farmer, instead of having 2 adjacent fields of monocrops, where you only have, in this case, you only have a slight interference on the edge of the 2 crops. But if these 2 crops were to be planted in a multi-cropping system, where you would have, for example, 1 row of corn, 1 row of soybean, etc., then you can imagine that all the soybean in the entire field, in the multi-cropped field, would be completely shaded by the corn, and therefore the productivity of the soybean would be very much affected. Yeah, probably the corn would not be affected because it's higher up and it gets all the light it needs, but the soybean would be definitely affected by the shade of the corn. So this is a good example why this farmer has them apart and did not choose to multicrop them. Of course, we know that in Mexico it's very common the corn and bean combination, but be aware that that is not simultaneous. No, they grow the corn, and once the corn is ready to be harvested, then they plant the beans, and then eventually the corn disappears, when the beans need the light. So a second argument to not put 2 crops together is if they are not compatible. And we already saw the first argument, if they have different heights and they affect each other in terms of light competition. We can also have a water and nutrient competition if one of the crops has a very aggressive root system, and where the root system of one crop affects the root system of the other crop. And we have clearly seen that in cases of combinations where pigeon pea was used to provide a quick shade for cocoa. So we see that on occasions where farmers plant cocoa and didn't anticipate that cocoa in the early stage needs a lot of shade. And then they see that the cocoa is suffering, and then they quickly search for a cover crop that provides the shade and would grow as quickly as possible. Yeah. And so pigeon pea is a very aggressive plant. It's a very fast growing plant. Well, you can imagine if you have a fast growing plant, it needs an aggressive root system in order to provide all the water and the nutrients for this rapidly growing plant. And so at this farm, that was also in Rio Dulce, fortunately it was only 1 lot, but we can see on the right that the cacao died underneath the pigeon pea. And then we dug up the soil, and because the farmer asked me, why is this cacao dying? So we dug up the soil, and we found that the root system of the pigeon pea had completely invaded the rootstock of the cacao and had, completely taken away water and nutrients, but also almost strangled the roots of the cacao, which are not that strong. And so this is another example where the two crops definitely are not competitive. And then there might be other reasons when the agricultural practices that I need to do on A would affect on B. We can think of irrigation. If crop A needs irrigation and crop B doesn't, then I cannot, in a multi-cropping system, I cannot irrigate A without irrigating B. Example, corn in the last 3 months of its life, it needs a drier soil and dry conditions so it can form its corn stalk, and it can so it wouldn't need water at that stage, at the final stage of the growth. Fertilizers needs. If the two crops have different fertilizer needs, I cannot, in a multi-cropping system, not fertilize A without fertilizing B, because all the roots turn out to intertwine. We will have that with spraying herbicides or pesticides. And also, if we have a sort of mechanized agriculture, if crop A is a grain that needs some tillage or going in, we could not do any tillage or other soil preparation or get in with the machines, because crop B wouldn't allow that. So there are some arguments where multicropping definitely would not be recommendable. So having gone over the purpose of multicropping and the aspects of why do it or why not do it, we now will dive into a deeper, maybe a little bit more academic part of analyzing how plants respond to solar radiation. We can see here the very, very basic chemical reaction of all plants on Earth and all green plants on Earth. What they basically do is a process that is called photosynthesis, which occurs on the leaves, on the green leaves. And in fact, for your curiosity, the reason they are green is because the photosynthesis uses all the red and blue light, and the green light cannot be used in photosynthesis, that wavelength, and so that is reflected, and that's why the leaves on the trees appear green. Yeah, but that is another curiosity. So what we basically see, what the plants do, is they get CO2 from the air, they get that, they absorb that through the leaves, through the stomates, into the leaf, and water is being hauled out of the soil by the roots, sent up into the leaves, and there the CO2 in the water is converted into sugars and oxygen, and then the sugars eventually are converted into biomass. Yeah? And that chemical reaction requires energy, and the energy for that reaction comes from the sun. So that's why it's called photosynthesis. Yeah? The biomass, the sugars, are then converted into roots, stem, branches, leaves, fruits, seeds, and that whatever it turns into is completely genetically determined where that biomass is then sent to. So this is really the basic chemical reaction that allows farmers to harvest whatever they're harvesting. Yeah? All right, so since this chemical reaction requires water, CO2, and light, as is normal in chemical reaction, the more CO2 we have, the faster this reaction goes. And this is an interesting and a very high research projects for the last decades has been how do plants respond in a world where the CO2 levels are rising? We all know that because we're burning fossil fuels, which is actually, everybody talks about climate change. But part of that climate change also is done due to an elevation of the CO2 content in our air. And actually, most crops will benefit from the increased CO2 levels in the air because photosynthesis is more effective. Also, the more sun there is, the more photosynthesis we can do. Yeah? And so being a chemical reaction, the more light and the more CO2 generally increase and help photosynthesis. And the more photosynthesis I have, the more biomass we create. And that normally converts into more fruits, more corn, more beans, more cocoa. So that is something that the farmer needs to manage. Now, here we have an example. This is some research we did a couple of years ago, looking at the response of sugarcane to the intensity of solar radiation. So we have on the y-axis, we have the photosynthetic activity, which in the literature is normally used by the letter A, and the units are micromoles of CO2 fixed per square meter leaf per second. Yeah. And on the x-axis, we have the intensity of the solar radiation. Yeah. And so at very low solar radiation, we have a low photosynthetic activity, and we can see for both cultivars, these are two lines, these are two different cultivars of sugarcane, and we see that both cultivars, the more light they get, the higher the photosynthetic activity, and there seems to be no limit. Well, we will see later on that there is a limit, but even beyond 700, we can see that even more than 700 watts per square meter, we still have increases of photosynthetic activity. And of course, the higher the photosynthetic activity of sugarcane, the more stock, the more biomass we will have, and the more sugar we will eventually harvest from the field. So this is a very typical response of plants to the different levels of solar radiation. But not all plants have the same response. Yeah. So if we look at the very similar research done by Dr. Bastide, and he did that on cacao, we see a similar curve but with different values. We again have photosynthetic activity A on the y-axis and solar radiation in watts per square meter on the x-axis. And then we'll see the same response. The more light there comes, the more photosynthetic activity the cacao tree does. But we see that it levels out very early. Around 200, this curve is leveling out. And we see that crop as cocoa, if it gets more than about 200, in this case, really there is no more photosynthetic activity. So that's why cacao is really a shade-tolerant crop, because it doesn't need more than about 200. Well, to give you a little bit of an idea, what reaches the Earth's surface from the sun, yeah, before the clouds, so not the Earth's surface, but the stratosphere, is 1440 watts per square meter. Yeah, so on a clear day, on a clear sky, noon, midday, we will have 1440 watts per square meter. Yeah, just in order so you can have a little bit of a reference of this x-axis, which is the solar radiation. And that number you can get off any standard weather station will provide you the solar radiation incoming at that spot at that time. So what happens if this cocoa receives more light than it can actually convert into sugars? Once it gets beyond the 200, all the solar radiation that falls on the leaves will not, the cacao cannot use it anymore for more photosynthesis because it maxes out. And then that additional solar radiation will be converted into heat and then cause tissue damage to the leaves. So if you get very much beyond the 200, then it is actually hurtful for the cacao because it will damage its leaves, and that obviously is not good for the cacao production. So if we look at different crops, I could make a very long list, and not for all crops we have data, but just to give you an idea, I look here at 5 crops which I got from the literature. Again, we can see the crop in the first column. Then the second column is the maximum photosynthetic rate, so the amount of CO2 fixed per square meter leaves per second. And then the third column is the light saturation point. So the light saturation point, we saw that in the previous slide, is where these 2 arrows connect. So this, let me put the pointer on here. Are we still all connected and listening?
Yes, we are.
Okay. I'm sorry, because I don't see your faces. I only see my screen. So, okay. So this for cocoa we call the light saturation point. Yeah. On the sugarcane in that experiment, we had not reached the light saturation point yet because it was still increasing. But in cocoa, it would be the light saturation point. That is the radiation where beyond no increased photosynthetic activity occur. So if you look at the light saturation point, cocoa in general is in the literature reported for 190, 200 watts per square meter. And only 1 or 2 varieties have shown to have a higher light saturation point. The very famous CCN51, which is very much used in Ecuador, apparently has a higher light saturation point. But most cacaos, the most varieties that we have in the world, will be around 200 watts per square meter. Now, if you look at oil palm, and then you see it only fixes 4 to 8. So it's not really highly photosynthetic active. If you look at oil palm, it maxes out at 522 with a rather high photosynthetic activity of 20 micromoles. Now, sugarcane is really the champion. Of course, sugarcane is a C4 plant, but if you look at this photosynthetic activity of sugarcane, it's amazing. And it maxes out at 800 to 1,000 watts per square meter. Remember, the maximum possible on Earth, on the clear sky, midday, sun overhead, would be 1440. So you can imagine that any shade that comes on sugarcane will reduce its productivity. Yeah. Here we can see bananas, and the literature indicates that there is a large variability in the different varieties of bananas, and the literature reports between 330 and 950, although most of the commercial bananas, the Cavendish, they are more likely to be around 800, 900 watts per square meter. And then we see coffee, also a rather low maximum photosynthetic rate, and also a rather low light saturation point. So what is the take-home message of this table is the lower the light saturation point of a crop is, the better it is suitable for agroforestry system, because it can tolerate an upper story forestry system without reducing its photosynthesis. Remember that if we reduce the photosynthesis, if the crop is operating most of the time below its light saturation point, its productivity will be reduced and the income for the farmer will be affected. Yeah? In fact, there is a couple of crops, and particularly bananas, for example. If bananas don't have enough photosynthetic activity during the time of the maturing of the bunch, then the bunch will be so small that it would be commercially not even interesting. So you would have zero commercial available bananas. Yeah. So this is something that we really, this is a key point in this presentation. So why is cacao such a shade-tolerant crop? It's pure genetics, but it shouldn't surprise us to see this, because where does the cacao come from? The origin of the genetics of cacao lie in the tropical rainforest of the Amazons in Ecuador, where it's an understory crop. So it probably, in most natural conditions, doesn't receive more than 10% of that full solar radiation. Yeah? So that's why it was always considered a shade tree. But in the 50s, they've started questioning the need of shade. And then today, we have successful plantations without shade in Ecuador, in Brazil, and in Ivory Coast. But again, we will now see in the next slides why that works in one site and why it doesn't work in other sites. And that's where we can look at here. We have the cacao growing underneath the sun. The sun, there's clear sky, there's no shading, so 100% of that solar radiation would reach the cacao. Under this condition, if this were the case, then the cacao would definitely be heated too much and would be damaged, particularly in the initial or early stages of growing the cacao. It would be very much affected by the excess of sun. So now if you have a cloud cover, as it occurs 7-8 months out of the year on the coast of Ecuador, we have a very interesting phenomenon. It's called the Humboldt current, where we have cloudy conditions almost 7-8 months out of the year. So that's why you see that in Ecuador you will see a lot of cacao as without shade, because you already have shading conditions due to this thick cloud cover, which probably cuts out 50 to 70% of the solar radiation. So what reaches eventually the cacao crop is only 30 to 50% of the total radiation. Well, the same effect you get obviously if you put a shade tree. If you put a shade tree that does its photosynthesis at a higher stratus, it also may take out 50 to 70% of the solar radiation, and therefore protecting the cacao crop for too much solar radiation. Now, if you had both conditions, where you have a strong cloud cover that takes out 50%, and then you have a shade tree that takes another 30-40% out, then of course you get only 10 to 20% of the original solar radiation reaching the cacao, and then its productivity would be very much affected. So we really need to analyze site by site what is the optimal density of the plants and how much shade should we need. And here we have an example in Granada, in Nicaragua, where we see a coffee crop underneath in an agroforestry system, which the forestry part has not been managed very well. They've just let the trees grow, and you can see that, you know, although they are very high, have their canopy high up, the density of the trees is definitely too much, and the production of the coffee in this case is very much affected. This is a slide where we have cacao with mahogany, and at this stage of the cacao, this mahogany is providing an optimal shading for the initial stages of this cacao. But probably very soon, in the next 2 years, as this cacao goes from the vegetative stage into the production stage, this will be excessive, and the shade trees will have to be thinned in order to not affect the productivity of the cacao. So how about all this solar radiation? We can get data from solar radiation. If you have a local weather station, you can get it from the local weather station. If not, you can find here on the bottom the link to a very interesting website. This is some work funded by the World Bank, where these fellows have made a world map of solar radiation. It was particularly intended for to see the potential for photovoltaic systems, but we can also use that for photosynthesis system. And now if we look at the part, and on that site you can get the world map, or you can put the country or the region, and you will get a map, and you can download the maps for free to really analyze this situation side by side. So if we look at this image here, I circled the main cocoa growing regions in Latin America and the Caribbean, where we have on the right, we have Bahia, Brazil. In the Dominican Republic, we have cacao. Throughout Central America, particularly Panama, Costa Rica, Nicaragua, Salvador, Honduras, and Guatemala. And of course, the big cacao growing country, Ecuador. You know, after Ivory Coast and Ghana, Ecuador is the third largest cocoa producer in the world. And if you see this, and you can see on the bottom, the color really indicates the intensity of the solar radiation. And in this case, you know, on the previous slides, we saw the watts per square meter, which is more of a momentarily incidence and intensity of the solar radiation. You can sum that up over a day, and then you get to an indicator which is called megajoules per day per square meter leaves. Yeah, and so now you can see why in Ecuador, in these growing regions of Ecuador, we have around 10 to 12, 13 megajoules per day on solar radiation. So that's why we understand why we don't really need shade trees, and where if we had many shade trees in the cocoa, the productivity would probably be hampered. But if you now look in El Salvador, where you have 24, 25 megajoules per day in solar radiation accumulated, then you can see that there, if you plant cacao without shade, it will absolutely die and will not survive the first 3-4 months of its life. And so in all these regions, both in the Dominican Republic, as well in Central America, as well in Bahia, it is very important to put shade in order to avoid damage of the cacao crop. Now, for our friends in Africa, I also downloaded the map for Africa. This is the map of sub-Saharan Africa, where we have the cocoa growing countries here. And you can clearly see that around the coast, we have lower solar radiation, and further land inwards, you can see that the solar radiation is very much increasing. So if we design agroforestry systems close to the coast or further land inwards, we will definitely have different conditions, and the shade tree density close to the coast should be lower than we have it further inwards, just because the more sun we have, the more shade trees the crop can tolerate. So here we have an example. This is the Lembrand's farm in Bahia, Brazil. It's a 200-hectare cacao farm, monocrop. We have solar radiations around 17 megajoules, so it's already more than necessary for the cacao. And the farmer told me, this is already a 20-year-old crop at the time of the photo. The farmer told me that he had a lot of problems at establishing the crop because many cacaos died in the first 6 months because of the excess sun. And it would definitely have benefited from more shade in the beginning. Now, once cacao starts producing, it needs more and more sun, but this crop at this condition could definitely tolerate maybe 30 to 50 trees per hectare, and this could be a very interesting case also for an agroforestry system where we would benefit from from the trees in terms of timber or nuts or fruits or whatever the trees would provide, and of course the carbon credits within the Acorn project. Now, this is a picture of La Chola in Ecuador. This is a 600-hectare monocrop cacao farm. In this area, we reach at the most 13 megajoules per day per square meter. You can see the cloudy conditions. Well, these conditions that you see in the sky will be dominant for at least 7-8 months out of the year. And so putting shade trees in here rather quickly would affect the productivity of the cacao. So in this case, we do not have an agroforestry system, and in fact, excellent results with high yields around 2 tons per hectare year, which is really very high for cocoa. Now, but on this same crop that we just saw on that same farm, we did some replanting, and you can see that even under those low light conditions, the seedlings, the just planted cacao is suffering from even the lower radiation causes sunburn. So at the establishment of this crop, it would probably have benefited from some sort of shade. After 6, 8, 10 months, the crops get over it, and then it doesn't suffer from the solar radiation in this case. Inserted here is we see the same situation in Antioquia in Colombia, where we also have rather cloudy conditions, but you can still see the yellowing of the leaves and the burning of the leaves at establishment of the cocoa crop. Now here we have a very creative and diverse agroforestry system with cacao, where the farmer really thought ahead of time of how to design his system. So what he did is he planted mahogany, a row of mahogany, then a little further he grew what is called mother of cacao. It's Glyceridia sepium. In Colombia they call it mata raton, but generally it's called mother of cacao, which of course, as its name already indicates, is a very suitable crop and is very compatible with cocoa. And so what his strategy here is he planted both trees at the same time. The mother of cacao grows very quickly and quickly provides shade for the cocoa. So 6-8 months after planting these 2 trees, he planted the cocoa, which benefited from the shade of the mother of cacao, while the mahogany was growing. As the cacao grows, he will then slowly eliminate the mother of cacao, and then the mahogany will stay as a permanent shade for the cocoa. This is also in Rio Dulce in Guatemala. And a couple of years later, this farmer even got more creative. And this is really my favorite slide of a well-planned and well-thought agroforestry system, where he planted the mahogany and the mother of cacao, but he put a third tree in there, which is rosewood. Now, if mahogany is a valuable crop, rosewood is probably the highest priced wood that you have on the market. But it's a very slow growing tree, and the wood is so highly priced because it's used for instrument, and even the branches can be used for instrument building. So what is his strategy? The mother of cacao is the short-term shade. The mahogany is the medium-term shade, and the rosewood will be the final or the long-term shade. So probably the mother of cacao at about 4 or 5 years will be slowly eliminated, because then the mahogany and the rosewood will start providing shade. He will harvest the mahogany in about 25 years, and the rosewood will be harvested at 40, 45 years. So here we have another example where this is in Rio San Juan, next to the Indio de Maíz Reserve in the Caribbean side of Nicaragua. The farmer bought this farm, which was an abandoned cattle farm, and it had already a secondary growth in it. And so you can see all these trees already rather high up. This is a secondary growth. And he thought, well, this is nice. I can put my cacao underneath it and have already enough shade for the initial stages of the cacao, which was true. But as the cacao grew, the forest also grew. And now as the cacao reaches its production phase, it has too much shade, and it will be very difficult under these circumstances to manage the shade. I mean, if he really wants to get a good cacao production, he would need to slowly start eliminating some of the secondary forest, which is very time consuming and expensive because it goes one by one and has to be very careful to not cause damage to the cacao tree. This is another good example in Guatemala, Rubel Santo, that is close to the border with Mexico, where the farmer also bought this farm, then planted plantain, musa, for export. So he planted 3 rows of plantain, and then 6 months later, he planted the cacao trees in the center. So we have 2-meter distance between the cacao trees, and then 4 meters wide of 3 rows of musa. So these plantain are used for export. He's really managing them very well. It provides him some early cash for this crop while the cacao is growing perfectly under the shade of the plantain. Plantain and cacao is an excellent combination because they're absolutely not competitive. The root systems are very compatible, and he will then slowly by slowly eliminate the plantain. He will get 1 crop, 2 crop harvest, and then slowly eliminate the plantain as the cacao is growing and needs more space and needs more sun. Unfortunately, he did not manage or plan a long-term shade. So this is a plantation that is now in problems because he did not provide the shade trees, because the solar radiation here is so much that this cacao will need some shade trees. And of course, he lost the opportunity to make use of an agroforestry system. He should have planted the trees right in the beginning so they could slowly grow and then provide shade and extra income and biodiversity for his agroforestry system.
Egbert, sorry to
Yeah.
interrupt. We have a slightly less than 30 minutes left, and I also thought of some time for questions. So maybe kind of like 20 minutes to go through the rest of the slides, Egbert.
That is perfect. That is perfect.
Great.
Yeah. So here we have another cacao plantain combination. This is in Ecuador with the low solar radiation, a very well managed plantain crop. Once the cacao is large, we get about 3, 4 to 5 harvests out of this plantain, and then the cacao will continue by itself because of the low solar radiation in this region. This is another example. This is the experimental farm of Mars in Sulawesi, Indonesia, where they use the mother of cacao as a shade tree, but the mother of cacao needs a lot of pruning because it continuously branches low, emits lower branches, which continuously physically affect the growth of the cacao tree. So although it is very compatible, I don't see it as a very good option for agroforestry because of this problem of a lot of hand labor needed to prune and maintain the mother of cacao. This is another mother of cacao with cacao plantation in Colombia, where they had the same problem of continuously managing and pruning the mother of cacao as the cacao grows. So what is very important if we look at cocoa, and the same would be for coffee, those shade tolerant crops, they need a lot of shade in the early stages when they are small and developing. But as they grow, cacao and coffee, need less and less shade, and once they start producing fruits, pods and beans, their shade requirements drastically reduce. Now, when you plant a shade tree, what the shade tree provides in shade is actually the opposite. So when they're small, they don't provide any shade, and the more they grow, the more shade they produce. So it's very difficult to manage this because we have really insufficient shade in the beginning and excessive shade at the end. So in agroforestry system where we have cacao and coffee, we need to really think of it very well. And if we plant shade trees, we will need some short, medium term shade options. And then the plantain is probably, in my experience, one of the best options. So now we get to the last and the third chapter of our presentation, and that is, well, what is the take-home message for a successful design in agroforestry, and how do we balance, the benefits from the trees and the main crop? So we saw here 4 good reasons to do multicropping. If there's mutual benefit, increased biodiversity, both crop and trees generate income, and we actually can increase effective area. So in terms of mutual benefit, what should we consider when we look at the mutual benefits? Remember that most crops produce less under shade. So not every crop is suitable for an agroforestry system, because when it's shaded, like bananas, when they're shaded, their productivity will be reduced. So let's look in an agroforestry system for plants that have a low light saturation point, as cacao and as coffee. And then we know that cacao requires a lot of shade in the first couple of years, but once productive, it needs less shade in order to be productive. Yeah. And then so the shade intensity is also very much related to the solar radiation on site. So please go to this site, download the map of your region, or go to the local weather station and look what is the solar radiation intensity accumulated over the day to see what are the shade requirements for the crop. In terms of biodiversity, as I mentioned before, the benefits of biodiversity are mainly on a large scale, maybe on a small farmer scale, 1, 2 to 5 hectares. Maybe the whole advantage of biodiversity with insects and all that may be less visible for the small farmer. Both crops and trees should generate income, so we should select trees that have a high, somewhat transparent, and not too extensive canopy. Yeah. Then we should select trees where the roots do not compete with the main crop. And select trees that generate some incomes, either nuts or fruits or timber, and of course the carbon credits with Acorn. In terms of increasing effective area, I would like to emphasize the design consideration. If we put the trees well distributed, equally distanced throughout the crop, we will have the best use of light, and we could manage the highest possibly density of trees because it's a lot more effective. However, thinning and harvesting will be difficult and could damage the main crop. So for thinning and harvesting consideration, it would be better to have the shade trees planted in rows, which would facilitate their harvest or thinning in case that were necessary. Try to maintain the plant spacing and density of the main crop because the main crop has costs of irrigation, of fertilization, a lot of management costs. So don't sacrifice the main crop, plant that as 100%, and then manage the tree density according to the crop stage. So early on, we should have a higher density or an alternative short, medium term shade from the plantain. and look at the solar radiation that occurs at the site that you are planning your agroforestry system. Of course, always use fences and roadsides to plant trees. That is a very common, most of the farms in Ecuador have 2 rows of teak trees besides all the roads, just to use up that space between the road and the field, which is normally about 3-4 meters. There they plant the teak trees, so they have additional biodiversity and additional income from those teak trees. And then, consider east-west planting if you want more light on the cacao, or north-south planting if you want to have more light on the trees and less on the cacao. And maybe on this last issue, I should elaborate a little bit in the case that on the top part, we have the planting north-south variant, and on the lower part, we have the east-west variant. Well, on the whole Earth, whether north or south, the sun always comes up on the east. Yeah. So in the morning, in this upper configuration, the trees will always shade the cacao on the left side. At noon, with the sun overhead, we don't have any shade on the cacao. And then in the afternoon, those same trees, when we have the sun on the west, they will shade the other row. So this is a very good combination when we have high solar radiation and need to shade the cacao, albeit part of the day. If we have less solar radiation conditions, then this might hurt the cacao, and then this might be a better variant where the sun comes up to the east and one tree shades the next tree. So the shade here really goes from left to right, from right to left, and the cacao will always receive light all day long, and noontime the same as above, and then in the afternoon the shade goes towards the right. So on the lower end, the shade trees will shade each other, so the growth of the shade trees will be less in the bottom scenario than in the top scenario, but we will have to see what is more convenient. Then we finish up with some other examples. So in this case, again, the Rio Dulce, this is a mahogany tree, and mahogany suffers from a pest, which is the Ipsipila, which is an insect that damages the growth point of the mahogany. And so that's why in the mahogany cacao combination, they start out with a rather high mahogany density, and then will start thinning out all the trees that have been damaged and will have no commercial value anymore, to slowly thin it out and then finish up with a density between 50 and 80 trees per hectare. This is another case. We have a farm here also in Rio Dulce, Guatemala. It was not very well planted. This farm had trees more than 80, 100 years old, very large, and then they started planting cacao underneath, which obviously benefited from the strong shading conditions. But now this crop is already 8 years old and is not producing more than 400 or 500 kilos cacao per hectare due to the tremendous shade that these old trees provide. This really has no other solution than losing money. This is probably my favorite combination of agroforestry, which I learned in Honduras. They plant plantain and the shade tree, in this case the mahogany. So they plant plantain at the same density as they will plant the cacao, and the shade trees already at their final density of 60. Yeah. Then 6 months later, when the plantain has grown enough, they put between 2 plantain, they put the cacao. So the plantain provides the shade for the cacao, and then slowly eliminating the plantain as the mahogany is providing more and more shade. And after year 4 or 5, the plantain is completely eliminated, and we can maintain the 60 mahoganies per hectare as a permanent shade for the cacao. This is an agroforestry system in Ciuna, Nicaragua, where we have teak with cacao. And this is a highly mechanized farm. They actually do the harvesting of the trees with machines. And so they planted the teak 8x4. And in the middle, after 2 years, they come in and planted the cacao. As the cacao grows, they will then, after year 6 or so, they will then take out a complete row. And between these two cacaos, we have 4 meters. And so the harvesting machine can go through here and can easily cut all this whole row without damaging the cacao. After this good experience, their latest plantings have been this configuration where they already leave them at 16 meters, the teak, at 4 meter distance, and plant already the 4 rows of cacao in the middle. And this has been a very successful design for this agroforestry system where we have 100% of cocoa, 1,250 cacaos per hectare, and then every 60 meter we have a row of teak. So, in summary, what we can say that agroforestry is recommended for areas with high solar radiation and with shade-tolerant crops. Both trees as well as the main crop should be carefully selected for their compatibility, their site suitability, and profitability. So please, before making an agroforestry system, sit down, do the numbers, do the design, think of different scenarios before starting it. And then pay attention to details in the design. Think of spacing, density, direction, north, south, east, west. Think of temporal shading, probably with planting, which is a very, very good alternative. And take advantage of the increasing effective area. Remember, for the farmer, this is very important. And then in case of tree removal later on, develop beforehand a thinning and harvest strategy for the shade trees to not later regret that you can't do that anymore. So with that, I would like to thank you very much for your attention, and I would like to open up the questioning session.
Perfect, Egbert. Very interesting presentation and with a lot of field experiences and insights. Yeah, we also put a poll on the chat. That's also something we included. But also feel free to raise your hand or put a question in the chat if you have any question to Egbert. I'll remain silent for a moment and let's see what pops up.
Yeah.
I see Maud. Go ahead, Maud.
Hi, Egbert. Thanks a lot for this presentation. I thought it was super interesting and really nice to see the other examples as well. Just a small question. I saw a lot of agroforestry designs mixed with timber species and mahogany and rosewood. What kind of fruit trees would you recommend or would be working best in Latin America to plant between the cocoa?
Yeah, fruit trees normally have a different configuration and they start branching out at very low heights. So already from 1.5, 2 meters, they start like citrus, for example, is a very famous example. You know, it starts branching out, and these lower branches really don't allow cacao to develop well. So I've seen these these citrus trees, for example, in cacao plantations, and really the whole area that the citrus tree occupies cannot be used for cacao. So there is a perfect compatibility, but you would not get the extra effective area because whatever the area that the citrus tree occupies cannot be used by cacao trees. And there is really no fruit tree where you have this long stem, because that's the ideal tree in agroforestry. If we want to use that effective area, that you will have a stem that goes up 4, 5, 6, 7 meters and then starts branching out and has its canopy higher up. That is really the ideal configuration for for the argument of increasing in the effective area. And that normally happens anyway with timber, because if you have timber trees, teak, mahogany, what you do is you always get these branches out, because the most valuable part of the tree is a long, erect stem without the branches. And so fruit trees will work very well. I've seen a lot of citrus trees in cocoa plantations, but so the compatibility is okay, but you would not have the extra area.
Thanks a lot.
I have a question, Egbert. Did you come across in Latin America certain species or fruit trees, nut trees that are really not compatible with cocoa and that we shouldn't consider?
To tell you the truth, not. Trees normally are not as aggressive in their rooting systems. The ones that are really aggressive was this pigeon pea, and I've seen other ones that are aggressive, and but trees normally are not aggressive, and that was the big reason, and that was the reason I had to go to this MLR farm in Ciuna, Nicaragua, because they said, ho, how do we know that teak and cacao are compatible? Because there was no other experience of teak and cacao that we knew of. And so when I went, the first thing I did is I dug up a trench. Cross-sectional trench from one teak to the other, so I could study the complete root system, a trench of about 80 centimeters deep. And I studied the complete root system from one teak to the other. And I saw a very perfect coexistence of roots from the cocoa and the roots of the teak. And that also emphasized again, because they are, in that case, they are fertilizing the cocoa, but there's no way of fertilizing the cocoa without fertilizing the teak. So the big question there was, if you want teak to develop well and have the, the value of the teak is the dark part, the maturing of that tree, and they were afraid that the teak might actually grow too quick because it uses part of the fertilizer from the cacao, and then may not develop into a good commercial tree. Well, we are now 5 years later, and it looks that is not a problem.
Okay, interesting. Yeah, thanks a lot, Egbert. Marjolein?
Yeah, thanks so much for the great presentation. Also, these insights. I'm really intrigued to hear more about the compatibility, and I just had like a thought or maybe a follow-up question based on your observations on the teak and the root system. In my experience and from what I heard in our Africa projects, or working with African partners on agroforestry systems, teak is often seen as incompatible, maybe because of water incompatibility or maybe, let's say, nutrient incompatibility. I was wondering what your thoughts are on that, and also what your thought is in general on the role of water or irrigation, because I know that in a lot of, I even saw in some of the pictures from, I saw some irrigation systems, which in African context is very rare. So I was wondering, maybe from that perspective, if you can share something about how water usage also influences compatibility.
Yeah. Well, if water is scarce, every square meter of leaves will use water. So if you want to see the water use of your area, you should really sum up all the what they call the leaf area index of all the crops. So if I have a single crop without anything else, I will probably have the least water use. And that's another thing, people say here, well, we put a cover crop underneath the main crop, and that maintains the soil fresh. No way. If you have a cover crop within your main crop, that cover crop does also transpire because it does photosynthesis. And there's no way to do photosynthesis without consuming water. In fact, they call water is so anyway, so if you have a cover crop, which is very good for soil protection, and erosion control, excellent. I'm very much in favor of cover crops because they really help, you know, they protect the soil from the direct impact of the rain. That is the case, but the cover crop does use water and will compete with your main crop for water use. The trees will probably be able to haul it up from greater depths. Nutrients, not so much, because most of the nutrients are in the first 20, 30 centimeters. There's very few nutrients down there, a meter. But water, yes. So trees will be able to use water from greater depths, which is not available for the main crop, which probably has roots down to 40, 50 centimeters. So yes, water competition should be very much thought of, and just think of every square meter of leaves will use water. There's no way around it. Otherwise, it wouldn't be growing. Yeah.
Thanks so much.
Great, Egbert. And considering if you have regions where you have quite a long period of drought, how does it work with cocoa? Is that something that is doable for the cocoa plant, or is there a certain maximum in terms of drought periods? Curious to hear your opinion.
Yeah. The regions I work, well, in Ecuador, all the cacao is irrigated because we have an 8 months, 7-month period of absolutely zero rainfall, cloud cover and zero rainfall. It's a very strange combination, and so it's all irrigated. I do not have personal experience in Africa, but a good friend of mine, Philippe Bastide, has devoted his whole career on cacao in Africa. And he, according to his data, which I find very reliable, he considers that cacao production in Africa due to drought probably reduces 30 to 40% of its potential productivity. Yeah. And so that is a very important, and you see it, and it's interesting that cacao, when it's drought stressed, the number of pods may reduce a little bit, but particularly the size of the pod reduces. And so your bean index just drops to the bottom.
Yeah. Interesting.
And so cacao, remember cacao, always look at the origin of cacao. It's a tree from the tropical rainforest of Ecuador. And so it's a tree that genetically was most compatible with year-round humidity in the soil. So if you take that to Ghana, because it was introduced in Ghana, it was introduced to Africa, it's not original from Africa. It was really taken out of its natural habitat. And that's why you see those sort of reactions, that you do have a strong effect on drought for the cacao production. Yes.
Okay, clear, Egbert. I see one person is typing a message in the chat. I think it's gonna be the last question. We have a question of Indira meanwhile. Please, Indira.
Yes, maybe I can. I have a question. At the beginning of the presentation, it was super nice presentation, Egbert. You mentioned that the effective area can increase to 0.4 hectares, right, for a new crop. But I was wondering, what does it represent in terms of the different type of trees regarding the selection? So can we relate this with the shade? So the level of shade that these will provide, because I believe that for different type of trees, the planting distance, so 0.4 hectares will represent a different number of trees. But how can we relate it or make it more like easy to follow? Maybe is with the shade has to be, because I also saw that later you also mentioned that the right level of shade is around 40%. So I was wondering.
Right. Okay. Very, very good question. So if we start from scratch, yeah, an agroforestry system from scratch, I would definitely recommend useful trees. Yeah, I would never recommend madre cacao or mother of cacao or other natural trees, because I think for the farmer, and I say this mainly for the economy of the farmer, he should get some benefit out of those trees. So that's why my main experience is with timber. The big advantage of timber, thinking of mahogany, thinking of teak, they have a long stem and don't have so many branches. If they were to be planted as a monocrop, mahogany and teak, at final harvest, you will probably be around 200 trees per hectare. Okay? So if we then are able to maintain 50 trees sparsed out in a hectare of cacao, then we have 1/4 of the density of a monocrop. So we have the hectare of cacao, and we would have 0.25 equivalent hectares of the shade tree. It's probably a little more because the shade trees in a monocrop obviously receive less light than if they're sparsed out. So they will grow probably quicker in the agroforestry system, only 40 or 50 spread around, than if they were to be in a monocrop. So that's why I go from 125. I would probably increase that number to 130, 140 equivalent trees. But if you have natural trees, they have in Latin America, you have this árbol de Guanacaste, which is a tree that just spreads out and has a diameter, or a saman, like you see in Tanzania, and it has a diameter of 30, 40 meters. And that really, takes up too much space. And then if it doesn't have any value except for the carbon credits. I think we should look at all these components. Hopefully it has carbon credits. Hopefully it produces some nutes or some timber. And so the farmer can really, has a diverse portfolio of incomes that he can count on.
Excellent, Egbert. Yeah, we're very much having a similar view with Acorn on that. I see, last question. We're a bit over time, but I think interesting for those that are still able to join now. It says, the person has already left, but agroforestry in old cocoa plantations that have more than 10 to 20 years, how can we manage that? And I think that's really something similar to the African situation.
First of all, I would like to say that I have all the time. So if this extends a little longer, don't worry for me. Okay, I'm available. In existing, what most farmers here are talking about, there is now quite some initiatives on genetic improvement of cacao. And so many farmers say, you know what, when in 10, 20 years, I have to get out all the trees, and with that, I damage my cacao, I will probably prune it down and how do you say that? Injertar. Grafting. Sorry. You would graft a new genetic material into that cacao. Yeah. So cacao is very suitable that you could cut it at 20 centimeter height. You have the stem, and you would graft a new genetic material in there, and you would probably rather quickly have a new crop if the harvest of the forestry system would damage it. Now, if you have an existing system of trees and cacao crops, first of all, the cacao should be much pruned, so the cacao doesn't grow out as much as you normally see we try to maintain a cacao no higher than 4 meters. Yeah? So it is really an understory crop underneath the trees. But thinning of the trees, I know we don't like it in the Acorn because we don't like to take out, the trees that we already committed to the project. But if the tree component has grown out of proportions, we should see if we can at least, prune the tree to at least, get the first 4 or 5 meters branching. And before taking him out, I would first try to get the branches, take care of the branches in the first 4 or 5 meters if you can do so. And that will probably already give more space and light to the cacao before taking them out completely.
Okay, yeah, very interesting, Egbert. And I think what you are mentioning is the system is top grafting, correct? That you basically cut the cocoa tree at relatively low heights, at knee height, then it starts sprouting, and you can do the grafting on the top of the old stem, basically.
Yeah. Because if it's 20 years old, grafting straight into the stem the survival rate is very low. So yes, you would wait until new shoots come out, and then you would graft into those shoots. That is very correct. Yes.
Yeah. Okay. I think we're gonna wrap up. Thank you very much, Egbert, for this presentation. I think it's very nice, and we can even think of certain other future lectures. I see a lot of relevant knowledge in this presentation. Also, thank you for all the participants. I do have a final question, and that is mostly also on what kind of topics would you like to be handled by this kind of lecture series. So if you have a certain topic that you feel like, oh, this is something I have that has a lot of value for me in my agroforestry project, in my Acorn project for the farmers, please leave a note in the chat. You can also, of course, email us or your account manager. So we can also capture all the needs that are among organizations and the people implementing agroforestry. That is, I think, finalization of this session. The recording will be available. We will follow that up somewhere over the next days and week to share the video, and hope many enjoyed. At least I did a lot. Thanks a lot, Egbert.
Thanks a lot for the opportunity. Bye all. If you have any questions, please reach out to me anytime. It will be interesting to continue looking at the designs and what can we do. Also, if there's a need for more emphasis on the cacao management, we could also maybe do some lecture on that. There's a lot to be done on the cacao management. And so we can also expand on that topic either in the field or virtually with this. So that will be very interesting to continue working on that.
Excellent.
Yeah. Thanks a lot.
Okay.
You have a good
Thanks,
day.
Egbert.
Okay.
Thank you so much.
Thank you.
Bye-bye.
Thank you very much. Bye.
Thank you. Bye-bye.